Hello, everyone, and welcome to today's webinar on the Creo Advanced Assembly extension, or AAX, one of the powerful extensions part of the Creo Design Advanced package. My name is Alex Janicki, Director of Marketing here at TriStar, and I'm very pleased to introduce our presenter, Emily Pinto. She's a virtual pre-sales specialist at PTC. Before we get started, I just wanted to do some real quick bookkeeping and mention that a complimentary recording of this webinar will be sent to everyone who registered automatically, as well as available on our website and YouTube channel shortly after presentation, usually an hour or two. If you have any questions during the presentation, please feel free to leave them in the little chat box there, and we'll hold a brief Q&A at the end of the presentation. But before we pass it over, I did want to go over TriStar for any of you not familiar with us. So at TriStar, we're a company that specializes in helping manufacturing companies adopt systems and processes to enable better and more efficient product development. We achieve this by being the largest value-added reseller for PTC products and services worldwide, with headquarters in Phoenix, Arizona, and representatives and engineers throughout North America, Canada, and Mexico. We've been in business for over 25 years, and we're experts in CAD, data management, PLM, and product development. Along with that, we have a large assortment of custom solutions, services, and support packages tailored to really specific needs and requirements. I encourage everyone to view the handout section. It should be located near the chat as well. It's got a nice brochure on AAX that you may view after the presentation. And as always, visit tristar.com if you want further information after this. And with that, I'm going to go ahead and make our presenter, Emily, take the reins here.
Great, thank you. Let me just make sure I'm sharing the right monitor. Can you see my PowerPoint? Okay. So hi everyone, my name is Emily Pinto. I work for PTC in the Virtual Center of Excellence. Thanks for the introduction. I'm here today to talk about Creo Advanced Assembly extension. Well, this is a special extension in Creo in that it opens up a new host of tools that you have available to you, a couple extra buttons that you get that allows you to change the way that you design your assemblies. And so instead of a bottom-up methodology where you create one part and you create a part off of it and you assemble them together and create a part that fits with those and assemble it together, instead you design the assembly at the start, and then you are able to do a top-down design methodology. And this, it has a couple of extra capabilities as well, and we're going to go through a quick PowerPoint to talk about what those key capabilities are and what what additional things you're able to do and take advantage of if you have the Creo Advanced Assembly extension. And then I have a demo to show you some of those different capabilities, what it looks like in Creo to work with. Now this tool really addresses a couple of key challenges. Now the concurrent design process is very time consuming. So if you have a bunch of different people or even different teams working on an assembly at the same time, all of these pieces have to come together at the end to work together and fit into this larger overarching theme that you're going for your model. And this is a very, very difficult process to manage when people are working at the same time. It manages a lot of different distributed design teams working in different areas, and someone needs to be able to rein everybody in. You see a lot of lost productivity and efficiency in these types of processes because of poor communication, which leads to errors and rework. So when you have everyone referencing different lines, building parts in ways that don't work well or fit together, have one person waiting for someone else to be done with a part so that they can use that part as a reference so that you know that they work together. This is a really inefficient process and results in error-prone models that are hard to change because everybody's working in a different way. So making a change at the end is very difficult. We see that there's an inability to securely protect and share company IP often in CAD solutions because you have limited tools to prevent unauthorized access or use of proprietary information and data. So maybe you work with suppliers or partners or someone who you really would like to share your design with, but you need their input, but there's some information about the assembly that you don't want everybody to have access to. It's difficult to share your model without sharing your model, right? We see that typically you either have access or you don't. And so this was another challenges that Advanced Assembly aims to address. We also see limited tools to support top-down design, which means it can be extremely difficult to define that assembly structure and enforce top-down design methodologies. As well, it can be difficult to manage assembly performance because you don't have tools that allow you to enforce design methodologies. And so Advanced Assembly helps you to do that, and we'll see how in just a minute. We also see a slow, tedious process often for designing assembly process planning documentation. Advanced Assembly allows you to do a lot of these automatically. So if you have large and complex assemblies, it's going to really speed things up and improve productivity. And so our solution, it's a collection of tools that speed assembly design and streamline the flow of information between design parties and also from design to manufacturing. So the capabilities here enable companies to effectively manage that assembly process and reach the optimal design in less time. So there are a couple of key concepts we're going to cover now. Number one, manage the top-down design assembly process. Top-down design is an incredibly useful methodology to use because it allows for more control over references, more control over what's happening. You can have that concurrent design process because everybody knows what's going on right at the start of the project. You don't have to have anybody waiting for anyone. Everything fits together at the end. And most importantly, you have flexibility at the end. So you can have these really large assemblies, have people working all over the place at the same time. It fits together perfectly, and it's incredibly flexible because you can manage the references. So top-down design is a great option. So if you're not familiar with it, this is definitely a good introduction. Advanced Assembly also supports design and build to order initiatives, meaning if you have different configurations or different parameters that customers are allowed to change and you're designing these or building them to order, there are different ways to support that with Advanced Assembly. Advanced Assembly is where you get that automation of design. So you're able to automate the design process based on incoming orders. You can also manage assembly performance, a lot of different ways to take large assemblies that maybe have performance issues. It's difficult to bring them up all at the same time and see everything you need. Capabilities here for managing that and allowing you to get the speed and performance even with large assemblies. Additionally, you can automate the creation of assembly process planning documentation so that somebody knows how to put this whole complicated thing together at the end. So touching on each of these, right? Top-down design is that first one that we mentioned, and this is supported in a couple of ways. So the first way that top-down design is supported with Advanced Assembly is skeleton models. You're able to use a skeleton model, which is essentially the plan for the framework of the assembly. So you can define the assembly structure. You say at the beginning, what are the key pieces of geometry? What is my assembly going to look like? Where are my boundaries between parts or important areas? And design that up front. And then you can even define motion skeletons to support mechanism design. So if pieces need to move, you can define that. You can also distribute this skeleton data to establish design criteria and support concurrent development. What that means is basically this skeleton model, let's say you're building this train here. Let me get my pointer out. Hold on one second. Okay, so you're designing this train. This whole profile of the train, all these green curves, maybe this is the outline that you make in your skeleton model. You want the profile of it, so you create these arches. You want to say where the doors are, so you create these surfaces, right? Where's the floor? This is all, potentially made in the skeleton model. And then when you're ready for concurrent design, you have, you want to pass this off for different people to work on. You can group these together and send them to people. So if you want the interior modeler to reference, you know, the interior archway, this door divider, the floor, right, the frame. Now they have a couple of key pieces of reference geometry that they're able to model off of right away. Everybody can work together and everything fits together at the end. So we'll see that in the demo. Sorry, I'm just switching my cursor here. So another really key piece is the reference viewer. You can actually graphically visualize dependencies and relations to understand change propagation. So you can share the referenced geometry into each group, so you have control over what's being referenced, and then they can view it and understand, right? If you go to make a change in the late stage, you can understand what everything's referencing, parent-child relationships. And this is where you get that control. So because you're able to define best practices and manage and limit the assembly component references, what are you going to attach your parts to, right? It's going to be those key pieces of geometry. We need to be logical about what everything references so you can keep your assemblies flexible over time. At the end, it's very easy to update and make complicated changes because everything's referencing only a few pieces of geometry, and you have the viewer to understand what's going to change where. So that's incredibly useful. This ties right into concurrent design. There's a data sharing piece of this. So when everybody can work together, you can have all the things you need to get started when you're ready to design your part right off the bat. So you can actually define and publish pieces of geometry, whether they're skeleton model or not, between sub-assemblies and components. So now, you know, this example takes that skeleton model idea where you have one piece of geometry that goes to, you know, engineer one couple of lines go to engineer two, they make their pieces, it all fits together in the end. This is great for concurrent design. If you have a key piece that you're referencing from a large assembly and you only need a couple of surfaces to make yours off of, not a problem. You can actually copy those into your particular subassembly or model, so you don't have to have the entire large assembly open just to create you know, a part that references those. So that's part of that concurrent design as well. Inheritance models are useful. This is something you get with advanced assembly that allows you to have one-way change propagation. So you can define an inheritance model, for example, to go to maybe new product updates, or to go to manufacturing, or to go to analysis. And what they're able to do is create a one-way associative model where they can make changes to their model, their assembly. Let's say you create an assembly that you're going to pass to your, you know, prepare it for manufacturing. So they can make changes, remove things that are going to be done in later processes, divide it up. None of the changes that they make are going to go back to the main model, the model that, you know, was created off of. However, if that main model is updated and you make some drastic late stage design change, those will automatically propagate to that model that the manufacturer, prepare for manufacturer, is using. So they will never be out of date. However, they can make changes without affecting everyone else's design work. So you can actually start doing downstream activities while you're still finalizing the design. Assembly configuration. This is an area that deals with automation. So there are two main ways to do this with advanced assembly. The first one is interchange groups. So we have tools like this interchange group to say, this part goes in the same way. And we have a couple of different versions of this part. So let's not waste time, you know, choosing a million references to be able to swap these in and out. Just choose the surface to mount it on and get along with the work, right? So for example, this piece here, this fits in this hole. Maybe you have 15 different versions of this piece. You can set those up in an interchange group so that you can simply swap them out in your assembly. You can right click, say swap for interchange model, and then pick the model you'd like. So you set those references ahead of time when you put them in that interchange group so that when you select it, it knows exactly how to be mated, you know, to the assembly. So it's very, very useful for configure to order type of stuff. You have a bunch of different options and configurations that people can do. Great, have your interchange group set up. So all you have to do is choose what options have been selected and you're ready to go. The other option is design to order. So these are actually, you know, changing things up based on what the customer orders in terms of your whole design. So not just a configuration. But you can actually define simple programs using Advanced Assembly to automate product line customization. So you're able to take parameters that are input by somebody. Let's say you don't just have different pieces of this. Let's say instead this dimension could change, and it could be anywhere in a range that the customer would want, right? The height and length of this. So you can have the definition of this backplate or something, or this circular cap defined by a simple program written in Advanced Assembly, or set up in Advanced Assembly, so that, let's say someone puts in a parameter and you say, great, let's have this automatically design what I need within my ranges, right? So it's pretty easy to define different changes to be made. So this actually drives the creation of a configurable product. So you could do this from parameters can come from spreadsheets, layout tables, programs, wherever it is you're getting that information. Okay, the last piece here, assembly process planning. This is an automated task with Advanced Assembly, so that you have this big complicated assembly. It's going to help you automate the process planning documentation, so that you don't have to dictate exactly how all of this fits together, and you want to use CAD data to do it. So it makes it much easier. It also generates associative manufacturing bill of materials for each assembly step, and then you can publish the assembly process plans for however you'd like to deliver those. So very useful. Now, talking about the last piece, visualization and product performance management. You only want to look at much data as you need to at a time with your CAD model, right? You don't want to overwhelm yourself. You don't want to overwhelm your system looking at things or having things up that don't need to be there. So there are a couple of ways that Advanced Assembly allows you to change your visualization for optimal performance management. One is the skeleton models. You can define functional subsystems and work within a large data set on just using only the key pieces of geometry that you need. So you don't have to have the whole assembly up just to be able to work with the geometry in it, right? So depending on what you're using, there are better ways to do this using Advanced Assembly. You're also able to take that shrink wrap and share these externally, so you can work within a shrink wrap, reduce your load time, strip a lot of that data from behind it so that you can still use the data, but you're not overwhelming your system. You can even share those externally. So that's another way to protect your IP, is to be able to shrink wrap this and then give it to someone, so they're able to evaluate your design, use your geometry, but they don't get any of your IP. Okay, so I know that was probably a lot of information, but I like to make sure we cover a full good description in the PowerPoint, because the demo, right, moves pretty quickly, and we're not going to get to look at all of this today. It's a little bit too much to show in one demo, but we'll cover a lot of the basics here. So this is this train assembly, and you can see it's a large assembly. Great candidate for Advanced Assembly, right? Large complex assemblies. Now to start looking at the first thing that we mentioned, using that skeleton model to share to different subsystems. So this can be used for top-down design, this can be used for concurrent design, this can be used for performance management, right? So that's what Advanced Assembly is all about, these extra capabilities that open up all these new ways to do things. And so what you are able to do is, this is the skeleton model, but really you could choose any geometry. It doesn't have to be part of a skeleton. You just select, you say, I want to publish some geometry, select the geometry that you want to publish, and you can give it a name. Now, published geometry just means you're grouping it. So you'll see it popped up, force structure is down there highlighted in the model tree. That's that new group of geometry that we made. And so we'll see what we do with that in just a second. But basically, you go to your model intent, you have an option for published geometry, and you're able to group geometry. So you can gather up a couple of different quilts or surfaces or chains, whatever it is that you want to work with somewhere else. We're actually able to take it from whatever assembly or part that this is in and copy it into another part or assembly wherever we want. So we're grouping these together so that we can take it somewhere else. I don't want to have this whole top level assembly open to do my particular work. So you can just have these particular pieces moved into the subassembly you're working in or the part. Now, down here in the structure assembly, this is where the structural, right, we published for structural geometry, that's where this is going to go. So there is a skeleton part in the structural assembly, and all you have to do to get that published geometry in there is say copy geometry and then select the group and hit say OK. So, right, you go into the assembly that you want and then copy it in there. So you'll see the same thing for the interior. So you select, activate the part you want to copy it into. So this is the skeleton. Select that published group, that for interior that was from the assembly above it. And now that geometry will be able to be in there. Now this is, it says copy, but they're always linked. So if one is changed, the other is changed, and we'll see how you have some controls over that. But you're not losing control of associativity, right? You're not opening yourself up for different versions. The way that this is managed, you can say, you know, if one thing is going to be changed, it changes everywhere. So you're really streamlining your process, right? Now, when you go to work with that, you'll see here in the structural assembly, those pieces of geometry pop up just like they were made in this assembly. This arch is from that top level, and now you can create it, you know, build the parts from the structure that you need. So whoever's working in the structural assembly can make the arch right from that line. No need to do anything differently, right? And the great thing about this now is that because that arch, that curve is connected to the top level skeleton, now if you go to the top level skeleton and make a change to that profile or a change to the dimensions of that curve, you are changing the shape of the train. Not only will it update, you know, this arch, but if you pattern it out, it's going to update everything. So now this entire structural assembly is able to be changed from the top level at any point. You know, all of these would update automatically. So when you're referencing things, you're able to control the references this way. So that's one way for top-down design and flexible assemblies at the end. You say here are the 10 pieces of geometry that I want to be able to change from the top level when this whole thing is done being assembled, right? The different boundaries between parts, the different profiles and shapes. And you'll be able to, you'll have the whole thing update automatically, all of the different pieces that are referenced off of that. So, you know, keeping your references managed, keeping your flexible assembly all the way to the end. So now let's look at another example from the interior. Now here you can see there are a couple of pieces geometry here, and this is just regular Creo work that you can do with it now. So you select a surface that you've created. Now you have from the top level, you have the shape of the windows and the shape of the exterior, where you can see that curve there. And so you can start doing your work, your regular Creo work. So you can have a sketched form punch come through, you know, cut that out of if you want to add a taper, cut that out of that interior wall. And this interior wall is being shaped by, of course, it's going to be shaped by the structural assembly, right? All the same things that were shared over there. But in addition, it's this exterior piece. So this exterior piece is going to cut the window so that it's always trimmed up to the window. So now if for some reason you make a change to say, oh, you know, I want the exterior to bump out a little bit, you know, that window cut will bump out as well, so that it'll always come right up to the end. So that whole, the depth of the window now and the shape of the window can be changed from the top level. You don't have a ton of references going everywhere. And most importantly, when everybody's done, right, the interior and the exterior don't have to, the engineers, they don't have to wait for the other to be done to be able to start working. Everybody can do all of this at the same time, because one person created the geometry that everybody uses right up front, and then everyone can get to work. So, you know, the great thing about this is it'll all fit together at the end. Now, taking a look at one more example, this has a shrink wrap in it, right? So this is for the door assembly. There's a shrink wrap structure. You can update it, so that would update with all the most recent developments of, you know, whatever anybody's done. You can see here you have that structural arch patterned out. You have the shape of the windows there. You have the shape of the exterior. The shrink wrap like I said, if you're not familiar, it wraps up your surface geometry, or rather wraps up what you see, and strips a lot of the data behind it, so you can have this whole assembly open and be able to see where's the floor, where the top. You can even reference those models, but you don't have to have all the weight of all that CAD data behind it, so you can effectively work in large assemblies. So, right, a couple of different ways that this helps performance management, because you can just take the piece of geometry that you need and you're good to go. Now, for this, we see the shape of the door. That actually, right, we happen to know that that came from the skeleton from the top level assembly as well, the shape of the door. And so it's copied geometry that's basically making this cut. It's it was published at that top level, and then we copied it into the door assembly right here. And you can see if you right click on that, you have options for control. Now, this is the control saying, if somebody at that top level assembly wants to make a change to the shape of this door, or for example, the curvature of this door, it follows along the external, right? It's the same shape as the exterior of the train. So if someone were to change the shape of the exterior of the train, it would imply that, right, this copy geometry could be set to automatically update. It could update with a notification. You can also do a manual update. You can also break the dependency. So the option here, this is a safety critical type of a piece. So we want to do manual update with notification, which means that we can design this door all we want, and it's going to keep the shape of the exterior. It's cut with that curve that you see kind of running along that external arch. And then if at the end, if someone makes a change, we're going to be able, it won't just automatically update. We can check it before we authorize that update to make sure that everything is working okay with the new profile. So we'll actually see that in just a second. But finishing this up, do your regular Creo work. You can shell it. This really doesn't change the way you design your parts. It just changes the way that you're sharing geometry and what you reference, right? So you can still design your parts however you'd like. That's why we say advanced assembly. It's just a collection of tools, right? It's not some crazy new way to design. It's a methodology. It's how you're doing it, how you're sharing it, not necessarily how you're actually making that geometry. So you can update this to top level representation. So all of these, you can change the representation that you'd like. You could have user defined representation. That's another option for performance management, is go in and create some user defined representations that have only the parts in it that you need. Now, one other little trick that we're going to have here to make a change is using something called design exploration. So if anybody is unfamiliar, this is not part of advanced assembly. Design exploration is its own extension. It's included in the base package of Creo now, that Design Essentials. It's included in that. So if you are on the subscription, you should have access to this. This is a wonderful tool that we use all over the place in Creo. And we definitely like to make users aware of. What it does is it gives you this checkpoint tree. And so what we've done essentially is opened a design exploration session. And the session, we can tell the session is open because we have the checkpoint tree, and it saves our model when we open the session as that pre-modified version. So no matter what we do to our model, to our assembly from this point on while we're in the session, we can always come back to this version that we opened the session with. So you can't break it. You're in essentially a sandbox environment. You can't break, if you break your model, not a problem, right? You can always exit the session without saving, and it's as if it never happened. It's as if you never opened the session or made any of those changes. So what it allows us to do is make maybe riskier design changes that we want to make sure, right, we have a backup without having to save a backup file, because that can get complicated with, oh, let me save this version of the file and back up here. You can accidentally overwrite, all sorts of issues. So that's where design exploration comes into a better way to do that. So for example, maybe we want to make a change to the skeleton model. So this is the skeleton model at top level assembly. This is how the profile is defined. A lot of different dimensions going on. What if you want to make a major change, like angling this in at the bottom? You've decided, okay, for some reason, tracks are narrow or something, you want to angle this in better for aerodynamics, but you can see everything's updating, right? Everything's regenerating. That's because all of the engineers who built things that are contributing to this were referencing that profile where they needed to. So anything that would be changed by that profile would automatically update. Now we did set one thing not to automatically update, it's safety critical. So instead of automatically updating the door to match that profile, it said, hey, there's an outdated feature. You need to manually check this. And it takes you right to it. So we can see that copy geometry. And we actually can see the door. So you can see that little gap at the bottom where, you know, there's the old door that you know, had the different profile at the bottom. Now you can change the update. You can update down at the bottom. You see updates. That would be accepting the change and saying, yep, we're okay with the door angling in at the bottom there. It's not going to cause any safety issues. The door is not going to fly open by accident. You can also do something with the differences. So you can actually see what was the outdated and what's the changed proposed change. And then you can choose to update it. So now this will update just like it would have if we had had automatic updates turned on. So you know, you can save this as a checkpoint. So this is the other benefit of design exploration. You're able to save as a checkpoint as you go. So now you have that shell change, that's that smaller profile at the bottom. You can keep designing, keep making changes. You can save checkpoints as you go along the way. If you decide you don't like the direction you went in, you can go back to a previous checkpoint and do something totally different, right? Make a different set of changes. You can basically go back in time and go in a different direction, and then you can save branches off of it. Again, you know, you can always exit this without saving anything. And so you can compare a lot of different versions, explore a lot of different options all at once. So taking a look at one more example of this, right? So for example, the arm of this chair. If you were to activate that, you could go into the sketch and make an edit. So right now those arms are floating. Maybe you don't want those arms to float. Maybe you want them to have this little, you know, support-ish type of a thing here. Now this is an armrest. You can view the changes. So this is that you're able to actually see what's been renamed, what's been modified, what's been deleted. You can even see reordered. And so you can see that that's been reordered. So this is another really useful tool. So the value here that we're talking about, just to summarize for advanced assembly, what benefits, right? What value can you expect if you adopt advanced assembly and the methodology? So the first, reduce time to market and cost. This is a really big one. You're able to streamline your product development by enabling concurrent design. Multiple people can work on the same assembly at different parts of the assembly at the same time and not lose time or productivity waiting for someone else to be done with their part so that they can reference it, or putting your parts together at the end and realizing they don't work, or worse, not realizing they don't work, actually building your product and realizing, oh my gosh, we have an error, we have an issue, there's a quality problem. So you can also drive predictable changes from the skeleton model. You know, you're able to control your references to keep them minimal and you know, to those key pieces of geometry. You're able to see your references with the reference viewer. So you're able to predict what's going to happen to your model, so you can make these large scale changes even at the end of your design. You also eliminate integration errors and rework. The other thing we see, increased product quality and innovation. You know, you're able to create and evaluate more concepts and ideas within the allotted time frame because you're not spending time on rework, you're not spending time on fixing problems or trying to get your pieces to fit together. You're able to make late stage design changes, so when you get everything done and designed and you realize, oh gosh, I wonder if it would have been better if we had done this, you're able to make those changes because you can keep your model flexible. You can develop and define new markets. This really revolves around the support, design, and build to order that advanced assembly gives you. Now, we didn't cover this in the demo, the interchange groups or the design automation. But if you have any kind of configured product where, you know, you have choices for what different, you know, substitutions you can do or what size you might be able to get, or you know, different parameters that you can do, different shapes. These are going to be really, really helped by Advanced Assembly because you're able to support these and drive them in an automated way. So you can drive them from tables, from parameters. You can swap things in and out with the click of a button once you have them set up. So if you're spending a lot of time doing different designs based on customer orders or different options that you give or different configurations, this is going to allow you to expand those capabilities, perform those tasks faster and easier so that you can focus on getting new markets and developing new products. So these are the main benefits of Advanced Assembly. I really hope that I was able to explain how this is used, why this is used, and whether or not this might be able to save you time or money or headaches in your design process. It's a really great option for a lot of companies, and we see it adopted all over. It's extremely useful. And if you have any questions, please put them in the chat or email Alex, email me. We can definitely have a discussion with you to see whether or not you think that this would be helpful.
Yeah, excellent. Thank you, Emily. We actually got one question that was kind of piggybacks right off the last part of the presentation. So will it notify you if your change created a rules violation in someone else's part?
So I'm not positive how that would work, but yes, I believe you could set that up.
Okay.
Alex, you and we can get back to them on that if you'd like.
Sure. And then, so is the assembly process planning, is that going to continue being supported in Creo, or is it replaced by another tool?
I haven't heard anything about it not being supported. So.
Okay.
Yeah, I wouldn't be able to.
And then finally, we got a question really early on. It was regards to slide 7, I believe. Are inheritance models only for parts, or can inheritance be used with assemblies?
Oh, actually, let me check on that one too.
Okay. Yeah, so these questions we'll go ahead and kind of reach out to you after the fact, do some little research. If there's any other questions here, we'll hold on for just a moment. All right. Looks like you left them speechless, Emily. Thank you, Emily, and thank you everyone who attended. If you enjoyed this presentation, we definitely encourage you to share the on-demand recording with colleagues or on social media. And then one final note, until the end of the month, so it's coming up, I think it's Friday, there's a nice promotion on upgrading to Creo Design Essentials or Creo Design Advanced. So if you've been waiting to upgrade and this extension looks of interest, we definitely encourage you to act fast. Reach out to one of our representatives at TriStar. Visit our website. You'll find additional replays, more information, free trial links. And if you want to set up, just a more in-depth demo on some of those features that she was speaking of, we can definitely do that as well. So thanks again, everyone, and have a wonderful day.
Bye, everyone. Thank you.